Hello everyone, welcome to another video of Calculus 1. In this video, I'm going to explain intermediate value theorem. Intermediate intermediate value theorem, also called IVT. What does this mean is that if there's a continuous function cannot skip values. Now it's easier for us to understand that using a curve or or a graph. Let's say this is f of x, and you have curve like that. Let's say it is continuous in the interval a to b, right? Now at b, the value of function of f of b, and at a, the value of function is f of a. Uh, Now this is a closed interval, right? So f is continuous in the closed interval ab. For all the values in between the FA and FB, right? For all the values M included in FA and FB, pick any arbitrary value. You should be able to find some value C. You should be able to find some value C, that is in interval AB, such that F of C should be equal to M. Now this F M should be equal to F of C, right? It's very simple. Now theorem can be explained by the diagram, right? If F is a continuous function in uh, on a closed interval a b, then for all m in fa to fb, there exists uh, at least one value c included in AB, such that FC was M. So if f of x is discontinuous, if f of x is like this, if you now at A, if A is this, and B, this is FB. Now we can find any value M, including, now M is in between, M is in between in this FA, within FA and FB. But can we find any C, in A and B, right? Such that f of c equals m. So it's not, right? F of c is not equal to m. So that it is in a discontinuous function, uh, intermediate value theorem does not hold, right? Now, why is this important? Why is this important? So it is important to find whether the function has zeros. What is my zeros? Uh, Zeros of a function means that the x values where the function value becomes zero, right? Now, if I show that in a graph again, if you have a graph like that, right? These are the points where the function value becomes zero. These are called zeros. Now, why is this? How can we use this uh, continuity of f of x and the intermediate value theorem to find zeros, right? We can find zeros by using that. Um, so one of the methods is called bisection method, right? Uh, we can use that method to find zeros. So, for example, in here, if I pick a closed region A and B, you can see that f of B is here and f of A is here, right? Now, if f of A is less than or equal to 0 and f of B is greater than or equal to 0 and f is continuous on the closed interval AB, then f must have a 0 in AB, right? F must have a 0 in AB. Okay, why? Because f cannot skip values. If value of f is changing from negative to positive, it should pass 0 by doing so continuously because it's continuous function, right? Because it is continuous function. Well, let's work on some examples and then you will figure this out. The first thing is that we can use intermediate value theorem to prove that functions have solutions in a given interval. So how do we do this is, let's see, this is in an example. So this is example one. You have proved that equation sine of x equal 0.3 has at least one solution in the interval pi/2. So we can, our function is f of x equal sine x, which is a continuous function in the closed interval pi 0 to pi/2. It's a continuous function, right? So if you draw sine x, this is x, this is 0, and that's pi over 2. It is something like this. It is a continuous function. Okay, this is positive 1, continuous function. And what is sine, what is f0? Sine 0 is equal to 1, f pi over 2, sine pi over 2 is equal to, oh, this is 0, my bad. This is 0, and this is 1. And point 3, somewhere in between this, can we find a value? Yes, because it's continuous, cannot skip values, so you should be able to find some value that satisfies sine x equal 0.3. 0.3 is in between 0 and 1, right? So then intermediate value theorem says that uh, sine x equal 0.3 has at least one solution, right? There should be a value. This is the m, right? There should be some x value that satisfy this equation, right? We don't know what that x value is. There should be some c value that satisfy that equation, okay? Um, you can use intermediate value theorem in that way. Let's work on got some couple of other problems. uh, this is problem 1 from book in this section. So we have g of t equals t divided by t plus 1. Show that g of t takes on the value 0.499 for some t in 0 to 1. Now consider this interval 0 to 1. Is g of t continuous? In this interval? Yes, it is continuous. G of t is continuous, and so we can find what is g of 0, which is 0, and g of 1 is half, right? And we'll see that 0.499 is in between 0 and half. So if I assume this is the curve of when t goes from 0 to, this is 0, right? And t equals 0, this is t, right? And when t goes to infinity, it should go to what? When t goes to infinity, it should go to dot 1, should go to 1. So it's something like that. So at 1, this is half. But at you can find 0.499 here, you will be able to find some value here, right? That's what it says. So yes, uh, 0.449 takes on value 445 for some t. That t we can find later, right? We can find that t, what that t value is. So yeah, so that's how you solve some of the problems. And then we will talk about this corollary of intermediate value theorem, that is this one, so that we can find the zeros of functions, right? If you know that f of a is less than 0 and f of b is greater than 0 and f is continuous in the uh, interval of a b, then you should be able to find a 0, right? Take this example. Take this example. This is the example. You are given f of x equals cosine squared x minus 2 times sine x over 4. Uh, show that f of x has a 0 in this interval. And then using bisection method, find a subinterval of 0 to 2 of length 108 that contains a 0 of f. Now first we'll prove that there's a 0 in between 0 and 2. So how do we prove? If f of x changing its sign within the interval, then there should be a 0, right? Let's see that. It's so easy, right? You find f of 0 first. What is f of 0? Cosine squared 0 minus 2 sine 0 over 4. Cosine 0 is 1, 1 squared is 1, minus sine 0 is 0, 0 is 1. F of 0 is 1. Then f of 2. F of 2, this is cosine squared. When you plug in the numbers in your calculator, should be plugged in radians, radian 2 minus 2 sine 2 over 4, sine half, right? And cosine squared, when you solve this, you'll see that it's negative 0.786. This is less than 0. This is greater than 0. Now what has happened? From 0 to 2, right? It's something like that. You are changing at 0, it is 1, and at 2, has become negative, right? Has become negative. Now the 0 is somewhere in between 0 and 2. We don't know where it is actually. And to find that, what we do is we make the uh, We use the bisection method. Bisection method is we bisect the interval and then find whether the function uh, changes its sign. So how do I bisect? So midpoint is half. So you take interval 0 to 1, right? When you take interval 0 to 1, right? When you take interval 0 to 1 at f0 is again 1, f1 is approximately equal to negative 2 uh, 0.03. Okay, so at 1 it is also negative. So within that interval, between 0 to 1 interval, function changes sign. Therefore, the 0 is in between 0 and 1, is in this region, this interval. Now what we do? We take 0 to half. We take 0 to half. So f0 again 1, f of half, f half is uh, f half is 0.5 to 1. Oh, now f half, when it comes from 0 to half, it doesn't change the sign. So 0 is not in between, 0 is not in between uh, 0 and half. So it is not in this interval. So which interval at 0 at? 0 is in half and 1 interval, right? Half and 1 interval. So if I get the midpoint, right, of this one, it is 4/3, right? It is 4/3. So I'm going to actually work out the rest of the problem here. So now we figured that this is half. So the 0 is in between these two region, right? Right there. Okay. So I take the region half to 1, right? Half to 1. You definitely know that the change sign changes, and then we make it we look at the midpoint of that. Midpoint is 4/3, right? And we take f 4/3. You will see f 4/3 is roughly 0.163. Oh, now half is also positive. F half is positive, right? F half is this positive. So half to 4/3 sign doesn't change. So 4/3 somewhere here, the sign doesn't change. So 0 is in between 4/3 and 1. 4/3 and 1. Now, what is the midpoint in between those two? Midpoint is 8, 7. Now, if you find f 8, 7, right, you will get negative point 2 0.0231 f 8, 7. Now, where's the 0 at? Now, from 7 7, 8 to 1 is all negative. From 7, 8 to 1, so 7, 8 to 1 is negative. This is 7, 8, it's negative. So 0 is in between 4/3, 0 is in between 4/3 and 7, 8. 0 is between, so okay, 3/4, 3/4, 3/4 and 7, 8, not 4/3, right? 0 is in between this. Okay, so we find that 1/8 interval. So the interval in between those two is 1/8 large interval. So that's how we find using bisection method. We find the zeros. Okay, let's do another example. Um, let's do another example. Uh, Example 5. Okay, 5. Show that cosine x equal x has a solution in the interval 0 to 1. And there's a hint. Show that fx hint that. So how do we show that? It's very simple because you need to show only the sign changes, right? So we find f at one end of the interval 0, 0 minus cosine 0. This is 0 minus 1, so it's going to be minus 1. What is f of 1? F of 1, it's 1 minus cosine 1, right? 1 minus cosine 1, so we need to calculate what cosine 1 is. If you do that, cosine 1 is equal to 1 minus cosine 1 is equal to 0.46, right? 0.46. So sign changes, right? So f0 is less than 0, f1 is greater than 0. Now we can see that the sign changed. F0 is -1, right? It was here, and then sign change. And if f1, this is 1, became positive 0.46. This is -1. This is f of x. What does that mean? There should be a 0 in between that. So there's a 0 for that function. So that has a solution. Okay. And let's say book 7, example 7 from the book. What does it say? Prove using IVT. So it's a proof using IVT. What need to be proved? You have to prove that this plus C plus 2 equals 3 has a solution. Has a solution. Um, it doesn't say us any interval, uh, but we can find any continuous interval, right? We can find any continuous interval. Um, what we need to do is create f of c. If it has a solution, that f of c is equal to plus c plus 2 minus 3 uh, should have a 0 in some interval, in some closed interval. So um, let's put c equals 0, right? Let's put c equals 0. So f0, you put this is 0 plus 0 plus 2 minus 3. So it's square root of 2 minus 3, right? Uh, it becomes positive. So this is negative, right? So this negative. So if you use the calculator, use my calculator, square root of 2 minus, sorry, minus 3. It's negative 5 point, negative 1.59. Okay. And f of 1, let's put 1. It's 1 plus 2 minus 3. Square root of 1 is 1 plus square root of 3 minus 3. So you get square root of 3 minus 2. So let's find square root of 3 minus 2. That also negative, negative 0.267, right? Let's find another value, f of 2, right? We do that, square root of 2 plus square root of 2 plus 2 minus 3. This is square root of 2, sorry, square root of 2. 2 plus 2 is 4. Square root of 4 is 2 minus 3. So it is square root of 2 minus 1. So I find the square root of 2, square root of 2 minus 1 equals 0.41. Oh, now the sign changed. So in the interval 1 to 2, right, the sign changed, sign of the function changed. So that means there's a 0. There is a 0 in 1 to 2 in interval. So FC, so this expression equals 3 has a solution, has a solution. Okay, uh, that's how you do this kind of problems. Let's take another problem. Uh, book 13. Um, you have 2 to the power x plus 3 to the power x equals 4 to the power x has a solution. Prove that, prove that has a solution, right? It's the same thing. So what we need to do is take f of x equals 2x plus 3x, sorry, 3 to the power x minus 4 to the power x has a 0. somewhere in x-axis, right? We will put positive integers, right? What is f of 0? F of 0 is 2 to the power 0, 3 to the power 0, minus 4 to the power 0. So 1 plus 1 minus 1, right? It's going to be 1, positive value. Let's take 1, 2 to the power 1, 3 to the power 1, minus 4 to the power 1. This is 2 plus 3 minus 4. This is 5. Uh, and it becomes 1 again, right? 5 minus 4 is 1. And I take f2. So 2 to the power 2 plus 3 squared minus 4 squared. This is 4 plus 9 minus 16. 4 plus 9 is 13 minus 16 is minus 3. Oh, sign change. Sign change when the function goes from 1 to 2. 1 to 2, somehow the function changed the sign, right? The function changed the sign. That means there is 0 in the interval 1 to 2, right? For function f of x. So function f of x is actually a continuous function in 1 to 2, right? It can assume all the values of x and everywhere it's defined. Yeah, so there's an interval in between that, 1 to 2. There's a 0 in that interval 1 to 2. Okay, so this is how you solve those problems. So with that, I will conclude this video. If you have any questions, please let me know.